Okay, today we're looking at Module 4, Lesson 12 on distributing expressions. We started the distributive property with the expressions yesterday when we used the GCF to pull out of the equations and expressions. I have to tell you, I've been teaching this lesson on distributing expressions for many years. I absolutely love the way this is presented today. I'm very excited. We have beautiful models to explain exactly what it means. So once we understand what it means through the models and the visualizations, then we'll move into just the solving. But I think this is a great lesson so that you can understand exactly what it means distributing expressions. And we're going to be creating equivalent expressions. All right, let's start with the basics. Draw a model to show 2 times 5. What did we say was another way to say 2 times 5? What would I have if I had 2 times 5? I would have 2 groups of 5. Remember, that's what that means. 2 groups of 5. So let's draw a model. So I have 2 groups of 5. Notice how both of the blocks are the same size because 5 is equivalent to 5. So we draw them both the same size. And we label them with 5, so we don't have to do 5 boxes and 5 boxes. Remember back in Module 1 when we did ratios, that a unit could represent any number, as long as we label that with a 5. Do you have a pencil she can borrow? Thank you. So now instead of saying 2 groups of 5, this example wants to see 2 groups of B, which we know we could also write it as 2B, right? When there's no symbol, that means to multiply. So if I drew 2 groups of 5, how could I draw a model for 2 groups of B? I made my boxes a little bit bigger this time, so that we didn't think B was equal to 5. Just copy your notes down. So 2 groups of 5, 2 groups of B. So far so good? Pretty straightforward? Okay. Now we want to write an expression that is equivalent, which means equal to 2 open parentheses, A plus B, close parentheses. Well, let's think about how we could read that. We could read that parentheses means what operation? Multiplication. So I could read that as 2 groups of A plus B, because of means multiplication. So I could read that as 2 groups of A plus B. So if I was going to draw a model, well, let's step back a second and let's just draw the model of A plus B. Do A and B have the same value? No. How do we know that? If they had the same value, they would have the same letter, the same variable. But since they're different variables, they have different values. So I'm going to make sure that I draw my A and my B different sizes. A and B. So that model is A plus B. Okay? Any questions on how I drew that? Yes? Well, right now we don't know. B could totally be bigger than A. A could be bigger than B. Right now we're just going to draw them different sizes. It could turn out that B is 2 and A is 17. But just the point is that they're not equal.
So, to represent 2 A plus B, we have to draw 2 of those.
Right. We have 2 of those now. So we had A plus B. So here's 1 A plus B. So now here's a second A plus B. Should have drawn that a little bit better. Here's 1 group of A plus B. Here's a second group of A plus B. So now did I show 2 groups of A plus B? I show two groups of A plus B? Yes. Okay. So in my two groups of A plus B, so this model represents that. How many A's do I have? Two. How many B's do I have? Two. Because I started with an A and a B, and I doubled both of them, right? And that's what I see in my picture. So we have two A's and two B's. And I see that in my second model. So by multiplying the expression A plus B times 2, I ended up with two A's and two B's. So if you were to turn around and put your, well, hang on 1 second. We're going to get to that in a minute. How would the model look if we grouped the A's together and we grouped the B's together? Because multiplication is commutative and associative, so the order doesn't matter. So let's draw our two A's together. Remember, our A's are the same size. And let's draw our B's together. How many A's do I have now? Two A's. And how many B's? Two B's. So what expression could I write? What did I create? Right, 2A plus 2B. So what we conclude is that two groups of A plus B equals 2A plus 2B. If we look at those models side by side, we have the same amount of A's and the same amount of B's. So those two expressions are equivalent. Any questions so far where any of that came from? Sure? How can we prove that? Because those are variables. How do I know that in the math world that's really equal? Those are really equivalent. What could I do to check it out? What could I do to check it out? Well, I already did the models. I want facts, concrete facts. Yeah, let's replace the variable with a number and see if it's true. So let's use 3 for A and 4 for B. So we have, write down the first expression. The first expression we did was two groups of A plus B. And I'm going to replace the A with 3 and replace the B with 4. Now I said that was equivalent to 2A plus 2B. So I'm going to replace my A and replace my B. If you want to use parentheses, you can use parentheses. Whoops. If you want to skip a couple pictures, you could skip a couple pictures. If you want to use the dot, you could use the dot. Now we just use good old-fashioned order of operations to solve that, and hopefully they will be equivalent. So 3 plus 4 is 7. 2 times 7 is 14. 2 times 3 is 6. 2 times 4 is 8. And when you add them together, it's 14. So are those two expressions equivalent? Yeah, exactly. So what happens when we doubled A plus B? What happened when we doubled A plus B? We had A plus B here, and we doubled it. What did we get? What did we get? No. We doubled A, and we doubled B. So both parts of that expression were doubled. Everything inside the parentheses was doubled by the 2 outside the parentheses. Remember, parentheses means to multiply. Multiplying by 2 is the same thing as doubling. Okay? Any questions so far? Alright, well, instead of 3 and 5 and A and B, let's use different terms. Let's try 3x and 4y. It's going to work the same way. Except now, instead of a variable, our term has a coefficient and a variable. But we're going to use the same steps. Okay? So how can I rewrite double 3x plus 4y? If I'm doubling it, that's the same thing as multiplying it by 2. So how can I write that? Right. I'm multiplying it by 2. If I'm doubling it, I'm going to have 2 groups. So 2 groups of 3x plus 4y. Now, is this in factored form, meaning I just see the factors? Or is this an expanded form where we see all of the symbols? Or neither? Actually, it's in one of them. Everybody likes that choice, though, today. It is in factored form because I see the factors listed. Remember, the factors are the 2 numbers that are multiplied together. If this was an expanded form, remember you did this for homework the other night, expanded form, you included all of the multiplication symbols, you expanded it all out. If you have the 2 times, that's the 2 outside, because the parentheses mean to multiply. Alright, so let's solve that. We want to find an equivalence expression that means doubling 3x plus 4y. So let's do it the same way. First, let's draw 3x plus 4y. So here's my model. I'm going to make my 3x a little bit smaller than my 4y. So that is 3x plus 4y. Does everybody agree that's a model? But I don't want just one of them. We want to double it. So here's 1. And there's 2. So here's one group of 3x plus 4y. And here's another group of 3x plus 4y. So I took the expression and I doubled it. So far, so good? Now, is there any matching that we could do? Can we rearrange them kind of like a puzzle? Can we rearrange the puzzle pieces? So that we have matchy-matchy on one side and matchy-matchy on the other side? What can I combine? What do I have matching? Give me one example. I have 2 groups of 3x. So can I do this? So I have I took this 3x and this 3x and I put them side by side. So how many x's did that give me? How many, if I have 3 here and I have 3 here, how many x's do I have? I have 2 groups of 3. So I have 6 x's all together. I have 3 x's in that square and 3 x's in that square. Now, I can also combine my 4y and my 4y. So how many y's do I have all together? If I have 4 y's here and 4 y's there, how many y's do I have all together? 8. Right. 8 y's. Okay. So I ended up having 6 x's, plus 8y. Did I change any of the amounts? So are these models equivalent? Granted, I didn't quite draw them equivalently, but are they equivalent? Do they have the same amount of x's and the same amount of y's? Yes. So an equivalent expression would be, what did we get when we had two groups of 3x? We had 6x's. And when we had two groups of 4y, we had 8y's. Now, drawing the models is great. I can see what it means when I'm multiplying something inside the parentheses by something outside the parentheses. But I really don't want to draw a model every single time. What operation did I keep doing over and over? What method could I use without using the model? Yeah. And what am I multiplying by? What am I multiplying by? The number outside the parentheses. Okay, so when there is a number outside the parentheses, I would multiply it by the terms on the inside. Because parentheses is just another symbol used to represent multiplication. So instead of drawing two sets of models, I could just multiply everything by 2. Instead of drawing 4 sets of models, I can multiply everything by 4. Whatever the number on the outside is, we can multiply it by the numbers on the inside. Now, let's think back. Let's look at this picture on example 3. Think way back. How would this be? This would be 3. Actually, I'm going to draw a better picture. I apologize. This would have been 3 times 2, right? 3 times 2. We did those with fractions earlier in the year, but you can remember arrays from when you were in elementary school. So that means 3 times 2. We've also seen something like that when we've done area. How would we find the area of that? 6 times 4. Because 6 times 4 represents this whole model. 3 times 2 represents that whole model. But now let's take a look at the model that they gave us for example 3. I have y here, and I have 4x, and I have 5. So based on what I already know, let's bring forward and apply what we've already learned about multiplication and arrays and area. What expression could I use for that? Beautiful. Y times 4x plus 5. Because how many groups of 4x do I have? Y groups. How many groups of 5 do I have? Y groups. I can't divide that. I don't know if y equals 2, y equals 3. We don't know what y is, so I can't separate that. But that model represents the multiplication. Great. So that's the factored expression, okay? It asked us to write it out in expanded form. This was the factored version. This would have been y times 4x plus y times 5, if we wanted to write it out in expanded form. Okay? How could rewrite this expression? Well, actually, I went ahead of myself again. I just went right, Naomi went straight to the right answer. I could say that it's 4. Apparently, I can't say anything. Y times 4x plus y times 5. That's another way we could have written it. These all represent the same thing. If you don't have them in the right one, that's okay. But these are all different ways that you could write the expression represented in that model, okay? But this is the easiest expression because we have that y factored out and it's the least amount of symbols. Okay? Let's try one without any models. Let's look at example 4. You just told me that I could multiply everything inside the parentheses by that number outside the parentheses. So let's look at the term 7d and multiply it by 3. We multiply the coefficients together. So if I have 3 groups of 7d, what do I have? How many d's do I have? If I have 3 groups of 7d's, just like we did earlier, if I had 2 groups of 3, but now I have 3 groups of 7.
21D.
Beautiful. And now if I have 3 groups of 4 E's, how many E's do I have? I have 3 groups with 4 in each group. I have 3 groups of 4. So I have 12E. And that's it. Those expressions are equivalent. We proved that by plugging in numbers. We proved that by drawing models. So we now know that those are equivalent expressions. And that's what they asked us to do. Find an equivalent expression without using a model. Any questions on like where the 21 came from, or where the 12 came from, or where the E came from, where my scarf came from? No, we're good? No questions? See if you're paying attention. I think I got a bit cold. Okay. Let's create a model for each expression below. So I only have number 1 on the board. So let's go ahead, try to draw a model. Think, how would I read that out loud? I would read that as 3 groups of x plus y. So how would you draw 3 groups of x plus y? Well, let's see. Remember, x and y have different values. So you want your boxes to be different sizes. One group of x plus y, one group of x plus y, and a third group of x plus y. But now, let's draw another model, because I can rearrange them, right? How many x's do I have? I have 3 x's, drawing them about the same size, because both models should be equal. And I have 3 y's. So what's this new expression that I was able to see from my model? 3 groups of x plus y equals how many x's? Plus how many y's? So 3 groups of x plus y equals 3x plus 3y. We multiplied everything inside the parentheses by that number outside the parentheses. Good? Try the next one on your own. Try number 2. So let's see, I have 4 groups of 2h plus g. have the cloning tool so I can cheat. I mean, take a shortcut. I would never cheat. Okay. I love this. I think this is such a great visualization. But I'm going to rearrange it now. I'm going to take all my 2 H's and put them together. I want them to all be about the same size. So how many H's do I have? 2, 4, 6. I have 8 H's. And then, notice how my models are about the same size. How many G's did I collect? 4 G's. So here's my new expression. 4 groups of 2H plus G equals 8H plus 4G. I see that right here. Any questions where they came from?
How did you get 8?
Because I had 4 groups of 2. 4 groups of 2 H's. So if I have 2 H's here, 2 H's here, 2 H's here, that gave me a total of 8 H's. Good question. Thank you for asking that. Anybody else have a question? All right. Just use the distributive property. We don't have to draw models anymore. We now understand that it's multiplication. So if I have 8 H's, I have 8 H's. If I have 8 groups of 3, I have 24. 8 times 3 is 24. Each term inside the parentheses is being multiplied by that 2 on, the number on the outside, which is times 8. So number 4. What's 3 times 2H?
6.
Right. And what's 3 times 7? Good. That's all you have to write. That's all that this is, equivalent expressions. What's 5 times 3x? If I have 5 groups with 3 x's in each one, how many x's do I have altogether? Right. And what's 5 groups of 9y? Yup. Number 6, what would the full answer be?
44H plus 12G.
Excellent. Very good. Ooh, another model that we're going to multiply here. So we're going to multiply everything by J. So I have 7K times J. So I have J groups of 7K plus 12M. If it helps you to write it that way, write it that way. You have J groups of 7K plus 12M. What do you think? So first, let's distribute to the first term. What would it be? Yes and no. How can we make that answer better than KJ? What is the rule about when we list our variables? Right, the variables have to be in alphabetical order. So 7JK plus
12SJ.
well, we're going to say JM so that our variables are in alphabetical order. Okay, you will lose points if you put MJ. The variables have to be in alphabetical order, so please make sure that's what you have written on your page. And 8. We're going to distribute the A. What is it going to be? This is A times 9 times B. This was your homework the other night. How could I write that?
A is 9AB.
Good. And A times 13, how would we write that? How would we write that? Right. And that's your answer. Okay, so the expression A, open parentheses, B plus C, close parentheses, represents A groups of B plus C. And we could use equivalent expressions by multiplying A by B and C. So we do A times B and A times C. And then you could add the two products together if you have like terms. If we're working, please don't close your binders. If we're still talking for all numbers, then we would be able to add them and solve. But with variables, we don't have matching variables, so we can't do that. Okay? So on tonight's homework, make sure you write the original equation and the equivalent expression. And if it asks for models, make sure you draw the appropriate models.